Scientists are terrified by the Andromeda Galaxy. Scientists found something shocking about Andromeda Galaxy, and they are very excited about the potential for new discoveries. The Andromeda Galaxy is about 2.5 million light-years away from us. It is the closest big galaxy to our own Milky Way. Using Hubble, scientists accurately recorded how the Andromeda Galaxy moved. They found that it seemed to be relocating at a speed of approximately 100 kilometers per second, almost straight toward the Milky Way. They thought that in about 4 billion years, the two galaxies would crash into each other, which would cause chaos. Hey smart people, welcome back to our YouTube channel. In today's video, we'll go to the Andromeda Galaxy and show you some scary mysteries. So watch this video until the end so you don't miss any details. But before we move on, don't forget to subscribe to our channel and click on the bell icon so you don't miss any of our awesome videos in the future. So let's get into it. In 2019, the measurements revealed that Andromeda was moving a little bit further to the side than was assumed before. This would put off the eventual collision by about 600 million years. But more recent results that employ more recent statistics have been published. And these results mean that Andromeda's sideways movement is still more significant than was assumed before. If the information provided is true, it is feasible that Andromeda will avoid the Milky Way on this specific pass. The weird thing is that even though all these metrics seem to go against each other, they all match up in some way. The issue is that readings are statistically unsure. This is because the sums involved are quite small and hard to figure out. The Milky Way and the Andromeda Galaxy are the two most giant galaxies. They are part of the galaxies called the Local Group. This group is composed of dozens of galaxies of different sizes that stay together because of their own gravity. Since Andromeda and the Milky Way are the two most enormous galaxies, they govern the group's gravitational effect and will thus decide what happens in the group. For example, if the two biggest people in the group always stay the same distance apart while they circle one another in a circle, then the team will remain the same throughout time. If in contrast, the two are headed straight for each other and will crash into each other, then this will change the group's members in a big way. When two large galaxies crash, they throw stars and gas in all directions, misrepresenting each other into weird and beautiful shapes. Ultimately, they combine into one galaxy much bigger than the other ones. The pace of an entity can be split into two parts: the radial velocity, which evaluates how fast something is moving toward or from you, and the angular velocity, which evaluates how fast anything is moving to the side. If something is traveling toward you at some pace, but not relocating transversely, you must gear up yourself for an influence. In contrast, if it has positive transverse velocity, it shifts both towards you and sideways while simultaneously timed. If the transverse velocity is high enough, it won't hit the goal. Even though nature has already made way for it to happen, it's not too hard to figure out how fast Andromeda is moving in a circle. Light waves change in a way called Doppler shift when an object moves towards you. This makes the light have a shorter wavelength. This is called blue shifting. Taking galaxy spectra is a relatively easy and accurate way to figure this out. It has been figured out to be about 100 kilometers per second, which is 360,000 kilometers per hour. Okay, but can you tell me how fast is it moving sideways? How fast is it moving to the left or right? The key question is this one. Andromeda is about 2.5 million light-years away. This is something to think about. Saturn is about 1 billion kilometers away from Earth, which is a very, very long way. The Cassini spacecraft got there after 7 years. Imagine that you went to Saturn and then came back to Earth. After that, do the same thing a billion times. At this spot, you have only gone as far as 1/10 of the way to Andromeda. Since Andromeda is so far from Earth, any movement in the transverse direction will look very small. This makes it hard to measure, and most telescopes can't even measure the tiny changes in their star's position that happen over a year. To find out how fast Andromeda was moving sideways, astrophysicists used Hubble over 5 and 7 years to make very accurate readings, which gave them a speed of 17 kilometers per second. This pace is much slower than radial speed of 100 kilometers per second, which means it is arriving towards our jet interval. Astronomers use the most recent statistics from the Gaia spacecraft, which evaluates the brightness, locations, movements, and colors of more than 1 billion stars with amazing precision. The technique is hard to understand, yet in the end, they found that Andromeda moves about 82 kilometers per second across the sky. At first glance, this shows that Andromeda would be disheartening to leave. The answer is yes, if the transverse and radial speeds are about the same, and 82 is close to 100. Then, all this means that Andromeda is moving at an angle of about 40 degrees to the side, enough for it to go right past the Milky Way. Then, which one is right? Oh, now we're getting to the interesting stuff. As I said before, these metrics are very hard and require a lot of supposition. However, astronomers can give their findings a statistical ambiguity kudos to the many statistical techniques they can use. For example, Hubble's first measurements had a range of error of plus or minus 34 kilometers per second. So, the correct number is 1,734 kilometers per second, which is the same as zero. In other words, it is going straight toward us. But from a statistical point of view, any speed between negative 17 and plus 51, think of it as having the same chance of going a bit to the left or a lot to the right because of how statistics are put together. It is difficult to rule out any velocity that falls within twice the ambiguity. It's less likely to be reasonably certain, but it is unlikely. This indicates that the speed could be anywhere from negative 51 to plus 85. Based on Gaia's latest measurements, the speed is 8,231 kilometers per second. That means it could be anywhere from 51 to 113, and you can't say for sure that it isn't any number between 20 and 144. There's a lot of room for error there. It's also crucial to note that the measurements made by Hubble and Gaia statistically overlap. The lower end of the spectrum of Gaia figures overlapped with the high end of Hubble's numbers. So, even though the nominal measurements of 17 and 82 seem to be very different, we can't rule out either one because there are so many unknowns. This is very frustrating. If the lower number is right, there will surely be a crash. If the higher one is it, we will certainly miss it, and we don't know which one that is. The good news is that this isn't difficult to figure out. We have nothing else to do but wait. We are trying to assess the apparent movements of stars over time. The more time between measurements, the more movement there is, and the more confident the measurements are. Since the first Hubble paper came out almost 10 years ago, it makes sense that the figures would be significantly more accurate if it were done again. Gaia is still gathering data at the moment. Gaia is expected to provide updated information very soon. Even after 5 years of the nominal mission have been processed, there will be a second release. The new data is expected to be much more precise than the information that came before it. So, if we give astrophysicists a couple of extra years, we will be able to get more accurate numbers. And then, we'll be able to determine whether we have to fix our safety belts for a cosmic collision in 1,000,000 or 2 light years, or observe Andromeda fly by us securely in 1,000,000 or 2 light years. Once we get to just that spot, we wish we'll know for certain. And that's all there is to this video. Let us know what you think about this video. And if you enjoyed this video, please like and subscribe to our channel to see more great stuff. We are so glad you watched this video. Please let your friends and family know about the video. We'll see you again in the next video.